Hey guys, welcome back. I'm going to show you how to integrate using trigonometric substitution. This can be found in a calculus textbook in chapter 8. It's not really spoken about by many teachers on the high school level, but definitely on a college level. So let's take a look. We know that the integral of 1 over the square root of 1 minus x squared dx is arc sine x. But what would happen, or how do we integrate the square root of 1 minus x squared dx? So this is actually how you do it, and it's not too challenging, it just takes a little while. We're going to let x equal sine theta, and basically it looks like a arc sine theta, so that's how you can remember it. And what we're going to do here is we're going to change everything to theta. So I'm going to go dx d theta, which is the derivative of x with respect to theta, is cosine theta. I'm then going to solve for dx, and then I'm going to just exchange all of this for thetas. So I get the square root of 1 minus sine squared theta, because that's what we made x, and then dx to be cosine theta d theta. We know that this 1 minus sine squared x, or 1 minus sine squared theta, is cosine squared theta, right? That's your identity. And then we know that if we take the square root of cosine squared theta, we'll get cosine theta, but then times that by this cosine theta, so you get cosine squared theta. So moving along, we have cosine squared theta d theta. Now, you are not allowed to integrate a trig function by adding 1 and then dividing it by the exponent. This is not a power rule. And we don't have any way of doing a u substitution. But hopefully your teacher taught you how to exchange cosine squared or sine squared with a double angle identity. So cosine squared theta is equivalent to 1 plus cosine double angle over 2. So you can rewrite this as 1/2, or you can pull out the 1/2 in the front, but I'm just going to rewrite it this way. I'm going to integrate 1/2 with respect to theta, so that's 1/2 theta. I'm going to integrate cosine double angle, which is sine double angle, divided by 2. So we're going to go with this here, and I'm actually going to exchange sine double angle for 2 sine angle cosine angle. So when we do a little simplifying, this and this will give you 1/2. So I hope everybody's with me. Slow down the video if you need to. I end up with 1/2 theta plus 1/2 sine theta cosine theta plus c. Now, basically we are done, but the only problem is that we started off with x's. So in the beginning, I let x equal sine theta. So I can do this part really quickly because that's just x. And in order to find cosine, what I'm going to do is I'm going to create a right triangle, put my little theta there. We know that trigs are always ratios, so sine is opposite over hypotenuse. We can fill out the adjacent by doing a squared plus b squared equals c squared, so that would give me this. And then cosine is going to be adjacent over 1, so therefore I get 1 minus x squared over 1. And then how do I solve for just theta? Well, I'm going to do the inverse of it. So I can go arc sine x equals arc sine sine theta. That would just leave me with theta. So some teachers will write it this way. And now you're completely done. So that's pretty much how you integrate this problem here. And I'm going to show you in the next video how to do it with tangent. Okay, so you're going to need to know your Pythagorean identities in order to do this. Have a great day.